All right, so now we've seen Pearson's correlation coefficient, and unfortunately it's sensitive. It's not robust, it's sensitive to all the observations. Secondly, as I said, it's a linear, it's looking for linear relationship. I'll show you next week when we get to regression, you'll see for yourself that it's sensitive to just a few observations. But in the meantime, just take my word for it. So what Spearman, now this is a name that's related to intelligence testing and all that, and what he came up with was a very clever idea. He said, all right, since we may or may not have normality, because the correlation coefficient is very much related to normality, that's the linear relationship, we may not have that in general, so what we'll do is we'll replace the observations with their ranks. And that's the Spearman correlation coefficient. Okay? It's exactly the same as Pearson's, except we replace their observations by their ranks. Right? Now, let me quickly remind you about ranks. So, for example, if we have these observations, these four observations, 1.7, 2.3, 2.3, 3.4, we would give them ranks 1, 2, 3, 4, except we say, these two are equal. Right? So what happens there? This is what we call tied ranks. Various things. It depends. What we could do is say both of these are the second smallest, so we'll give them rank 2. Or we could say both of those are the second largest, so we'll give them rank 3. Yeah, you could do that. Another one, which is much more popular, is give them the ranks they would get. So give them the ranks they would get if they weren't equal. So smush them around just a smidgen. And so in this case, this one would get rank 2. Let's say that one would get rank 3. Then average out that rank and give it to both of them. So each now would get rank. So this is one way of doing it. It's the most popular way, and it's what most people do. It's sort of like saying, so you tied for second place. We'll take the second place money, we'll take the third place money, we'll put them together, and you'll both get the same amount of money. Okay? So we even out the prizes. It's not that bad. You might say, I object to this because look at this. It's giving me fractions when I had pure numbers. I want just pure numbers. This is the worst it gets. Because if you have to do it for 3, suppose 3 of them even out, then they all get an integer rank. So any odd number even out, then they'll get full integer ranks. If an even number even out, they'll each get something ending in 0.5. So that's the worst they can get. I'll leave that for you to prove for yourself. Okay, so let's go back to Spearman. And so what Spearman said was, okay, rank the data. So I've made up 4 fake numbers here. And so here are the x's and the associated y's with those x's. So you got 4 people. And now let me rank these x's. So here is the smallest x. The 0.8 is the smallest x. It gets rank 1. Then 1.3 is the next larger. It gets rank 2. Then 1.4 is the next largest. It gets rank 3. And then the 1.7 is the largest. It gets rank 4. Okay? So take your x's, rank them, and then throw them away. So just retain the ranks. Do the same thing with the y's. So here's the smallest y, then that's the next smallest, and then that's the next one, and then that's the next one. And so here are the ranks of the y's. Throw that away. Replace your data with these data, and then you go back a couple of 2 or 3 slides back, and use this as your data, and call up the Pearson's correlation coefficient, and there it is. That is Spearman's correlation coefficient. Okay? Now, the nice thing about Spearman's correlation coefficient, as we always say, don't worry about this, Stata will calculate it for you. Well, it turns out that this thing reduces very nicely when you do Spearman's by introduce another variable here, which is the difference. So the difference between the x ranks and the y ranks. So 4 minus 3 is 1, 2 minus 2 is 0, and so on, then the Spearman's is just equal to this. So if you're on a desert island somewhere, you don't have stata, and you want to do a Spearman correlation coefficient, then there it is. Just take the differences of the ranks, sum up the squares of the differences, divide by this thing, and you've got it. Okay? Don't worry about it. As I said, this is just a nice, I couldn't resist. All right, so here is the, going back to our DPT example, here, you know, the immunization percentages, those are probably not normally distributed. Maybe we shouldn't do Pearson's. The mortality rate, that's probably not normally distributed, so we shouldn't do Pearson's. So why not do Spearman's? So here it is. So here are the countries. This is percent immunization, and the countries are actually ranked by their percent immunization. Then we look at the mortality rate, under 5 mortality rate, rank them accordingly, look at the D's, and then the D squareds, and then we can calculate the sum of the D squares is 2,169, and so there is the Spearman's. So that's RS. Spearman's correlation is minus 0.631. So there's a very negative correlation. What does that mean? It means exactly what you thought. If you're high number in your rank, that means you do a high degree of immunization. If you've got a small rank, you've got a low mortality rate. So this is exactly what you want. You want the high to go with the low. So you want a negative correlation. And that's exactly what we have here. And we've got a negative correlation, minus 0.631. Now, it turns out that in this case, the Pearson's was not that far different from this anyway. But it's safer to just go with the, when you have any doubts about the correlation, when you have any doubts about the distribution of your X's and your Y's, whether they're normal or not, go with the Spearman's. It's not that different, but it buys you a little bit of safety. And now, the other beauty of Spearman's is that this word linear doesn't appear here. This is truly a test for independence of these two characteristics. All right? Unfortunately, it only has power, it's only got reasonable power when you're testing the hypothesis H that rho is equal to 0 versus the alternative that rho, now this is Spearman's rho, is not equal to 0. All right? So, but here it is anyway. For this minus 0.631, we're getting a T with 18 degrees of freedom at with a very, very tiny P. Okay. Here's another situation where you would certainly want to do Spearman's. What this is every year there's this group of watchdogs, if you will, of the medical profession in this country, and they watch and they look at how much disciplinary action is exercised in each of the 50 states. Actually, it's each of the 50 states plus District of Columbia. So each state does it their own way. Each state has a medical board, and the medical board decides what to do about physicians who go who do wrong. Okay, so here we see this is the correlation between the ranks in 1991 and the ranks in 1992. And we see that apart from this here and here, it looks like there's a very strong correlation. In fact, there it is. Spearman's correlation is 0.8102. So here we don't have to assume anything about the distribution of what it is that these people are measuring. We're just looking at their ranks. And it looks like, it's very strange, but it looks like that from one year to the next, how the medical board acts is highly correlated. So I don't know. Why should that be? Is it because some states have all the bad doctors, or some states have all the bad medical board? I don't know. But this is repeated. So here is what we call a matrix plot. And what we've got here is their rank in 1995. Here's their rank in 94, their rank in 93, their ranks in 92, and their ranks in 91. And each one of these little plots here, so along this line, so that's for this plot, this plot, this plot, this plot, the rank in 95 is on the vertical axis. And in this column, this one, this one, this one, this one, a rank of 94 is along the horizontal. So what we're sort of seeing is that here they tend to be a little tight. Now that's with 1 year versus the next year, the subsequent year. But they looks like they're loosening up as they get 2 years apart, 3 years apart, and 4 years apart. So I looked at this, what is this? This must be 15 years ago or so. And I saw this, and I couldn't figure out why that is so. If you look at the Spearman rank correlations, you can see that along this diagonal here, which would mean 1 year apart, they're a little bit higher than 2 years apart, 3 years apart, 4 years apart. You can also ask for the significance value, and you can ask for it at the Bonferroni, and it tells you at what Bonferroni level, and all of them are significant here. These are all significant. So this was, as I said, this was about 15, 17 years ago, and the question is, have things changed? So we got the data. I got the data now from 2003 to 2011, so updating what we had before. And here is that same matrix, this time with the first one is for the year 2003, 2004, 2005, all the way down to 2011. And now it looks to me like we've got much tighter. When they're 1 year apart, they look much tighter than they did before. So why is there this tightness like this 1 year apart? 2 years apart, they're starting to get a little bit more varied. 3 years apart, it's opening up some, and so on. So there's the 3 years apart. 4 years apart looks, but you get the picture. You get the picture. Why are they so tight? And here it is. Here's the Spearman correlation coefficient. And you can see along this diagonal, it's like 0.9 or so. Along this diagonal, going up like that, it's 75 or so, and so on. There's this going up. It gets higher and higher. The closer the 2 years are together, the higher the correlation. And if you go to Bonferroni, you see that they are all significant except this one. This one disappears, so it's not significant. I did this at the 0.05 level at the Bonferroni. What does this show? I don't know. What does this show? I don't know. I leave it up to you to interpret this. Does it mean? Is this just an example of something we know very well, which is that on these medical boards, there's a lot of physicians on these medical boards, and so what do we know? We know that groups of people cannot police themselves. They're not good at policing themselves. Maybe this is just a manifestation of that. I don't know. But there it is. So that's Spearman's correlation coefficient.